Hi, I'm Bob. Welcome back to the solutions for the exercises from the textbook Microeconomics Theory and Applications with Calculus, the 5th edition. We have now reached Chapter 14, which focuses on oligopoly and monopolistic competition. Today, we will be addressing questions related to the Cournot Oligopoly model. Here's exercise 3.1. What is the duopoly Nash-Cournot equilibrium if the market demand function is Q equals 1000 minus 1000 times P, and each firm's marginal cost is 28 cents per unit? It is a Cournot oligopoly model. We take two steps to find the Nash-Cournot equilibrium. In the first step, we determine each firm's best response function. For firm 1, its residual demand equals the market demand minus the amount consumers purchase from firm 2. Then we can relate the market price P to the firm's outputs, Q1 and Q2. We can write firm 1's revenue function in terms of Q1 and Q2. Firm 1 operates as a monopoly with respect to the consumers who purchase its products. That is, firm 1 can think of itself as having a monopoly with respect to its residual demand curve. So, we can solve for its output as if it were a monopoly. We derive its marginal revenue and use the first-order condition for its profit maximization. Marginal revenue equals marginal cost. We simplify the first-order condition and write it as the form of the best response function, expressing Q1 in terms of Q2. We see that the best response function is indeed the first-order condition for profit maximization. By symmetry, we can write firm 2's best response function. We can draw the two best response curves in a graph. The Nash-Cournot equilibrium occurs at the intersection of the two best response curves. Therefore, in step 2, we solve the two best response functions simultaneously for the Nash-Cournot equilibrium quantities. Each firm produces 240. Finally, we substitute the quantities into the inverse market demand function to find the Cournot market price, which equals $0.52 or 52 cents. Another method to find the Nash-Cournot equilibrium is using firm 1's best response function and knowing that the two firms' Cournot quantities should be the same by symmetry. Let's solve exercise 3.2. In the initial Cournot oligopoly equilibrium, both firms have constant marginal costs, M, and no fixed costs. And the market has a barrier to entry. Use calculus to show what happens to the best response function of firms if both firms now face a fixed cost of F. The best response function is indeed the first-order condition for each firm's profit maximization with respect to its residual demand curve. The first-order condition concerns the marginal revenue and marginal cost. The fixed cost will not affect each firm's decisions. Therefore, the Nash-Cournot equilibrium is unchanged. Facing the residual demand, the firm operates like a monopoly. Like any monopoly firm, the fixed cost will not affect the profit maximizing or loss minimizing quantity. It only affects the firm's decision of whether to enter the market. Let's answer exercise 3.3. It's about the reason for the increase in the oligopoly price. Some believe that it is obviously not driven by increasing global demand, but rather by fixed costs being proportioned across significantly lower demand. If the firms are oligopolistic, produce a homogeneous good, face a linear market demand curve, and have linear costs, and the market outcome is a Nash-Cournot equilibrium, thus the firm's explanation as to why the market equilibrium price is rising makes sense. We will explore the reason for an increase in the Nash-Cournot equilibrium price. Suppose there were n identical firms in the market. Each firm has a constant marginal cost m. In the first step, we derive the Nash-Cournot equilibrium price. In the second step, we examine the factors behind the change in the price. For a linear inverse market demand curve, P equals A minus B times Q, where the market output Q is the sum of each firm's output. We can write Firm 1's revenue function and its marginal revenue function. Firm 1 operates like a monopoly with respect to its residual demand. The first order condition for its profit maximization is marginal revenue equals marginal cost. It leads to Firm 1's best response function, equation 1. By symmetry, each firm should produce the same output in the Nash-Cournot equilibrium. The best response function becomes an equation with one unknown. We solve for the Nash-Cournot equilibrium quantity, Q star, which is A minus M divided by B times 1 plus N. Substituting Q star into the inverse market demand function gives the Nash-Cournot equilibrium price P star. In the second step, we determine how the parameters A, M, and N affect P star. The partial derivative of P star with respect to A is positive. It means if A increases, then P star increases. We can draw the inverse demand curve to help us understand the parameter A. For the linear inverse demand function, A increases as the curve shifts to the right. When the curve shifts to the right, the market demand increases because for each given price, the quantity rises. So the result implies that, holding other factors constant, when the market demand increases, the Nash-Cournot equilibrium price increases. The partial derivative of P star with respect to M is also positive. It means the market equilibrium price will increase if the firm's marginal cost increases. The partial derivative of P star with respect to N is negative. It means as the number of firms in the market increases, the equilibrium price decreases. Therefore, the reasons for an increase in the Nash-Cournot equilibrium price could be an increase in the market demand, an increase in the marginal cost or a decrease in the number of oligopoly firms in the market. The firm's explanation does not make sense. Thank you for watching this video and subscribing to my YouTube channel. See you next time.